So take your note packet out, please.
Wow. Wait, can you get that? Wait, so what is it called?
Taxonomy.
Taxonomy?
It's on your packet. So in this unit, we're going to be talking about a few different things. We're going to start off today and the rest of this week and some of next week talking about taxonomy. And then we're going to move in and start to talk about how we classify and what the different groups of living organisms are and what their characteristics are and so forth. Okay. So here's some definitions we'll be using later on. You get a packet, right? Take a packet, staple it. So, taxonomy. Probably a word you haven't really heard, but taxonomy is a science of how we classify things. Classify means sort of putting things into groups based on their characteristics. And so, humans have been classifying things for thousands of years to put things into categories that help us understand things and their characteristics. And so, by classifying and putting organisms and living things into groups, it helps us sort of understand how living organisms are similar to each other, how they're different, how they may have evolved. And so the science of taxonomy is one that's been studied for a long time. The system we use today, our modern system of classification, started really with this guy, Carolus Linnaeus. His actual name was Karl von Linn, but he changed his name to sound more Latin. Does anybody take Latin? No one takes Latin?
Spanish.
Okay. Well, Carl Linnaeus is known as the father of taxonomy because he sort of came up with this system. Kind of like we might call Darwin the father of evolution. And Carl Linnaeus came up with a system of giving all living organisms a unique name. We call that their scientific name. This system is called binomial nomenclature. What does the prefix bi mean? A bicycle? No? Two. Prefix bi means two. Nomial means name. So it's a two-name naming system. Every species that's been identified by scientists has a two-part name. For example, see that tree back there, the white bark? What would you call that? If you know anything about trees? Birch?
A birch.
A birch tree. That is a paper birch tree, I believe. It has a scientific name. It's called Betula apirifera. This tree out here, you know what tree that one is?
Probably oak.
That evergreen? No. It's a pine, a specific pine. That's a white pine tree. Its scientific name is Pinus strobus. Okay? And that's a sugar maple over there. That's Acer saccharum. So all species have this scientific name. Humans have a scientific name. Does anybody know the scientific name for humans? Okay? Homo sapiens. So every species has its own scientific name. And they all sound sort of strange because they're based usually in Latin. Linnaeus, when he was coming up with this system, he used Latin as the language for these scientific names. And he did that for a couple reasons. first off, where do people speak Latin today? Nowhere. Latin is not a language that is used in daily conversation anywhere. It's the language of ancient Rome. Okay? And so, because it's no longer used, it doesn't really change. Like Latin has a certain set of vocabulary and words, and it doesn't change. Other languages that are currently spoken are constantly changing, and words change in meaning and so forth. So Latin is a dead language. No one really speaks it, so it's sort of set in stone. So it's a good language to use to name things. Also, it's not specific to one country, okay? Because it's not spoken in any country as their typical language. And so it doesn't favor any one part of the world versus another. And so Linnaeus used Latin as his language, and that's why those tree names I was giving you all have sort of a different sort of sound, because they're in Latin. Little joke there. So again, tomato as Solanum lycopersicum, tomato. A potato is Solanum tuberosum. That's their scientific name. So why do we have names for those things, like tomato or potato or pine tree, sugar maple tree? We have words for those. So why give them another name and make things more complicated? Well, there's a couple reasons. First off, often, so when we say pine tree or potato, we call those common names, just our everyday names for things. And they are sometimes misleading. What is that?
Jellyfish.
Is it a fish? No. It's not a fish at all. It also doesn't taste delicious on toast, so jelly is misleading. So that's a common name, but it could be confusing because it's not a fish at all.
Seahorse.
Is it a horse?
No. Kind of, because it
No. What is it?
has-
What is a seahorse? It's a fish. Ringworm.
I got one.
Ringworm.
Ew, wait, is that?
Yeah.
Okay.
Is it a worm?
No.
It's actually not a worm at all. It's a fungus. Okay, it's like a skin infection that people get sometimes. It's caused by a fungus. It's not a worm. Starfish?
What's the picture? It's not even.
Is it a fish?
No.
No. Is it a burning ball of hydrogen? No, so it's not a star either. So those names could be confusing because they're sort of misleading. Also, what? It's an echinoderm. You'll be learning that soon. So those common names can be misleading. Also, people from that speak different languages, scientists have to collaborate with each other and talk to each other about different types of living things. I'm doing some research on tomatoes, and somebody in another country that speaks another language is also doing research. Well, the word for tomato varies from language to language. In English, obviously, it's tomato. In Italian, it would be pomodoro. Okay, two different words. But if we're working on the same species and studying the same species, if we use the scientific name, then we know we're talking about the same thing because we're going to use the scientific name for that species. You've seen these cartoons before?
Yeah. Yeah.
Did you ever see at the beginning, in like the introduction,
They have a bunch of words.
they're like running, chasing each other,
Yeah,
and then they freeze frame it, and they show underneath it a little caption. What they give are like sort of joke scientific names for those species. Really, a roadrunner is a real bird. Its actual scientific name is Geocossix californis. But like on the cartoons, the names they give it, Accelerati increditus, is very fast. Or they call the coyote Edius birdius. Really, the coyote's scientific name is Canis latrans. And so they give them those names as kind of jokes. Okay? And so they sound Latin, but they're just made up words, they're not real Latin words. But that's why they have that little section at the beginning of the Roadrunner cartoons. So when we classify things and put them into groups, we have a whole series of levels of classification that we use. We just talked earlier about, right, we just talked earlier about kingdom. That's one of the higher levels of classification. But there's others, and you're going to have to remember them. So the very, very top level is a level of classification called domain. It's a very, very big group. There's only 3 domains for all living things go into one of these 3 domains. The next largest group that we talked about is kingdom. Again, it's a huge group. There's 6 kingdoms of living things. And as we continue to go down further, after kingdom comes phylum. And as we're moving down, we're getting more and more specific. The number of organisms in each group is decreasing. After phylum, we have class. After class, we have order. Then we have family.
Family?
And then the last 2 are the genus and the species. Those are our 8 levels of classification, our 8 taxonomic groups. Like we said, sorry, hold on. As we go from up here to down here, we get more and more specific. There's fewer and fewer organisms in each group, and the relatedness of the organisms gets closer as we move down. When I was giving you the scientific names for those species, like Acer saccharum, that scientific name is made up of the genus and the species of that organism. So for Acer saccharum, the genus for sugar maple tree is Acer. The species name is saccharum. That's how we make these scientific names. So if we look for a minute here at some organisms, we won't include domain here. We'll start at kingdom. So all of these organisms are in the same kingdom. So a bear, a grizzly bear, a black bear, a panda, a red fox, a squirrel, a snake, and a starfish, all of those are in one kingdom, the animal kingdom. So that's like a huge variety of living things. Lots of different things are animals. So then if we go the next level down and get more specific, we get to phylum Chordata. Phylum Chordata are all of the vertebrates, all of the animals with a backbone. So what got eliminated? The starfish. It's not in the chordate phylum. It's in a different phylum. So now, again, still it's a wide variety, but they're a little more similar to each other. Then we go down another level into class. Class Mammalia. These are the mammals. So what did we get rid of? The snakes. Okay, these are all mammals. And so now we're getting more similar to each other. We know mammals have certain characteristics. If we go another step down, carnivora. These are a group of mammals, okay, that are often meat eaters and have canine teeth. And so again, the squirrel's out. The squirrel is a rodent. We go down one more level to family. Now we're getting much more specific. Ursidae is the family of bears. All bears are in family Ursidae.
Is a panda a bear?
Yes, that's why it's in the family Ursidae. But it's, so these are obviously pretty similar. Then we go down to genus, genus Ursus. This includes these bears, but the panda is in a separate group.
Why?
Okay, just because it has sort of different characteristics. And then finally we get down to the species level. And there's only one thing left. Ursus arctos. Okay? Ursus arctos is the scientific name for a grizzly bear. So as we go down these levels of taxonomic classification, like I said, we get more and more specific. Let's look at humans. Okay? So we have a couple ways to help, because you're going to have to memorize those levels of classification. Oh, my video posted. From domain down to species, and we'll talk about that in a minute. So to help you with this, there's a couple ways we have to help you remember. First, there's a sentence or a couple sentences you might use. There's one which is not that exciting, but if you remember it, dear King Philip came over for great soup. The first letter of each word stands for one of the levels of classification. Another sentence you might remember, it's a little more memorable. It's a little violent, not that nice, but dumb kids play catch on freeway, go splat. Not too nice. But if it helps you remember, I also have a little video here that might help you remember.
Hey, at least tell them the truth. About the kids go splat.
All right, so let's look at where do humans lie on this classification scale. So we start with domain. So the domain, which again is the top level, the broadest, most general category. Humans are in a domain that's called eukarya. I guess we'll list these first. So domain, kingdom. It's the next level. What's the P stand for? Phylum. Raise your hand. What about the C? Jordan? Class. How about the O? Human, phylum, class. Tyler? Order. The F is easy. Kaya? Family. How about the G? Emily? Genus. So it's not like me, genius, but like genus. There's no I in there. Genus. And finally, our last level, Branda, species. All right, so where do humans fit in here? Well, our domain is called eukarya. That is a huge group. So we are in the domain eukarya, but so is a maple tree. So is a mushroom or a worm. So things that are in the same domain might be very, very different from each other. They do have a couple things similar, but there's a huge variety. How about our kingdom? We listed kingdoms at the beginning of class. Okay? Yeah, animal kingdom. We're in the animal kingdom.
What does it mean?
We just talked about it with the bears. Phylum. We are vertebrates. We have a backbone, a spinal cord. That phylum is called chordata. Chordates. Our class is something you're familiar with, mammals. We are mammals. Order within that, we are primates. Primates include monkeys, apes, things like that.
So we're all monkeys?
No.
Apes?
Nope. Now, from here on out, humans are the only species in this family, genus, and species. So the family that humans belong to, okay, is called Hominidae. hominids, sometimes called. And there are no other hominids except for humans. The genus is Homo, and the species, sapiens. Homo means man, sapiens means knowing. Knowing man is what our scientific name means. Homo sapiens. And so, our scientific name is Homo sapiens, okay? Because you get a scientific name by combining the genus with the species. We'll come back to that video in a moment. Because I want to just finish this last slide. So, this process of giving all organisms a two-part name, it's called binomial nomenclature. Here are 3 types of bears. We talked about them. Panda bear, polar bear, grizzly bear. Here are their binomial names. The giant panda, scientific name, is Alleropoda melanoluca. A polar bear is Ursus maritimus, and a grizzly is Ursus arctos. So they're all have their own specific scientific name. Which two are most closely related? Emily? How do you know that? Yeah, almost the same, right? They're not the exact same name, but they have the same, what was this? Ursus, what is that? They're both in the same
Category. Kingdom.
Which, not kingdom, genus. They're both in the same genus. They're in the genus Ursus. They're different species, but they're in the same genus, which means they're pretty closely related. The last thing is about how we write a scientific name. There are certain rules we have to follow. First of all, it's the genus and the species, and we capitalize the genus name. We don't capitalize the species name. You'll notice in each of these examples, the U or the A has been capitalized, the M or the A has not. We capitalize the first letter of genus, and that's all. The other rule is about how we write it. We underline scientific names if we're writing them by hand. Or if you're using a computer, you would make it in italics. You could see that's how they're written there. All right, questions about binomial nomenclature or taxonomy so far? Okay, I'm going to show you that video and then the brain pop if we have time. Okay, stop.